Hello and welcome to today's webinar. My name is Dr. Lena Weigold and I'm Product Manager at Retsch. Today we are talking about our innovative cutting mills with a focus on cleaning. You will receive the presentation afterwards and you can always ask your questions during the webinar or after the webinar. We are happy to give you an answer to your questions. Now, the role of cutting mills in your lab is this is an indispensable device for milling and homogenization, especially if we are talking about soft, medium hard, tough, elastic or fibrous materials. If you are talking or if you have other samples with other properties like very brittle materials or materials that contain a lot of water, you should use another mill, for example, a jaw crusher or a knife mill. We have a lot of mills in our portfolio, but today we focus on cutting mills. And where the name already says, we have the physical mechanism of cutting and shear forces to mill our sample materials. So the mill is especially suited if we are talking about heterogeneous materials. They can be also slightly sticky or made from polymers, plastic materials, or slightly temperature sensitive. But we are always talking about monolithic pieces. We are not talking about fine grinding, make high fineness from powders, but we are talking about pre-crushing. So if we have, for example, 50 millimeter feed size or an amount of 1 liter, this is perfect application for a cutting mill. You can see here some more examples for single monolithic materials that you want to grind. Already seen the result that is achieved from the cutting mill, plastic parts, wood pieces, dog food, a toothbrush, also electronic parts, yes, and many more of these kind of samples. If you have fluffy or fibrous materials, this is also an application for cutting mills. Hay, textile, cardboard, leather. And the last group of materials that can be used together with the cutting mill are bulk materials, for example, bark, seed, oat, soybeans, herbs, or animal feed. Now, we have different cutting mills in our portfolio. We have 3 floor standing models, the basic one, SM100, and a more advanced model, SM300, with more features and high performance grinding. You can see here you can attach a cyclone. Also, you have variable speed, fold back hopper. And we have a new member in our family, which is the SM50. It's a tabletop cutting mill. And for this presentation today, I focus a little bit on what you have asked or signed in the form where you registered for this webinar, and what do you want to know from us if we talk about innovative cutting mills. You want to understand how do you get high fineness, good fineness, what is the performance of a mill, sample recovery, you mentioned it several times, this is an important point for you. How do I handle the mill? Can I mill contamination-free? And of course cleaning, which is the main topic for today. So of course fineness depends on our cutting performance. You can see here a rotor and a knife, and these are the cutting blades of the milling chamber. And you see they are double acting, so you have 18 cutting events for each round. And you adjust the gap best to 0.3 millimeters to get a good fineness. Every single piece of material that is cut finer than the bottom sieve falls down to the receptacle. So the bottom sieve defines the final fineness. We have bottom sieves ranging from 20 millimeters down to 0.25, so 250 microns. Depends on the sample properties, which one is suitable. Also, 2-step grinding should be a possibility. So first do a pre-grinding step and then a fine grinding step. The performance of the mill very much depends, of course, of the motor power, but also of the design. And you can see here we have SM300, the high performance and the high power, a very powerful mill, has a RES technology, which means rotational energy storage. So we have a mass wheel, which is mounted on the motor shaft. So we have an advanced power, which is necessary if you are talking about very massive, hard or big pieces to overcome blockages. So we can achieve up to 20 kilowatt. And we have the variable speed. So speed is important, motor power is important, and also rotor diameter is important. You can see it here in the graph. This is the speed of the machine, and this is the cutting velocity, where at the tips where the knives of the rotor are located. And we have a quite large rotor design, so 130 millimeters. And as you can see here, cutting velocity is very high thanks to the high speed and to the large rotor size. So this is why we offer a very good and powerful cutting performance. Sample recovery is important because you want to get a representative sample for your analysis. So you want to get everything that you put in the machine, you want to get back. If your material is not heavy enough to fall down in the receptacle by gravity forces, you can use a cyclone. This helps you to bring fluffy, fibrous, lightweight materials out of the milling chamber and into the receptacle. So for this, you're using a vacuum cleaner and the cyclone, and it's simply mounted here. Or I can also show you the setup for the SM50, because here the cyclone is integrated. So it's part of the machine setup. Because here we focus on small sample amounts, and it's even more important to get back all the sample after grinding. So in this video, we can understand how cyclone technology works. We feed the machine, the material falls into the milling chamber, and the cyclone helps to bring out the material from the chamber to the receptacle. So the cyclone separates material from the airstream of the vacuum cleaner. Let me give you some videos to explain the features that we have. Let's start with a tennis ball, which is quite difficult to grind because it's elastic and round. So we use 6-blade or 6-disc rotor to cut it like shifted and not in one time. We use a 10 millimeter bottom sieve. It's a pre-crushing step, and the receptacle. You have seen it. I mounted the receptacle underneath the milling chamber. 3000 RPM. And with the plunger, we force the material to the knives, and this is how the result looks like. In the next example, I want to emphasize that even very hard and tough materials can be cut with a cutting mill. Very important, use the 6-disc rotor here because they have very stable cutting tips, and the high motor power overcomes blockages, so even possible to grind the circuit boards. And now a third example. This is a rubber material, so very elastic, and we have experienced that it's sticky. It tends to stick at the surface. So we embrittle it before we grind it. You see, we have a bath of liquid nitrogen, and we change the properties from being elastic and tough to hard and brittle. And with the 6-disc rotor, we get very nice result. Or here it's a 3-disc rotor because we only have half of the depth with the tabletop model compared to the floor standing model, and of residues in the mill. Now, if we talk about fine grinding, so we want to achieve higher fineness, we use another rotor. This is a V rotor and a fine sieve of 1 millimeter. And the cyclone technology, because the material is fluffy. We want to grind the tennis ball, again, after the pre-grinding for fine grinding. And you know it's fluffy and it will not fall down by gravity. We use the cyclone gravity technology to help bring out the material from the chamber. Yeah, and this is the result. Also for leather, textile, or other like plastic foils, you should use the V-rotor and cyclone to get a fine powder. And the standard rotor, this is the parallel section rotor, is used for standard applications, for example, wood pieces, which is easy to grind. Simple grinding between the knife of the rotor and the blades of the milling chamber. Yeah. Now another very important point for you and another challenge for us to make a very nice design is the handling. So we want you to get a very easy and intuitive experience when you are milling your samples with our mills. This is why we offer different hopper types. This is a batch feeding hopper. This is the universal hopper. And here we have a long stock hopper for long materials. So you are able to feed or to have a nice simple feeding of your sample. And we offer different collectors, the glass, also 3 and 5 liter receptacles, and also bigger receptacles like up to 30 liters that you can simply connect with a hose to the machine. And the cyclone is we used here too. Every machine has small features that helps you to have an easy handling with the machine. For example, motor brake, so it stops quickly after you finished your grinding. It also is kind of a safety reason. If you want to open the door during a milling process, the motor stops. You are not able to open the door, so there's a security lock to avoid injuries. We have a nice door opening here. We have a touch display with functions, different functions, a push button in case you want to use or you have to use gloves. You can start and stop the machine and also select the speed. And we have a very nice feature with SM50, which is the rotor release. So in case you have a blockage, you can release the rotor shaft and you can turn the rotor in the opposite direction to remove the material. Contamination-free milling is a very important point if you are preparing sample for analysis. You do not want to contaminate your samples so that your analysis result is false or wrong. So we offer our machines and the tooling of different materials: stainless steel, aluminium, heavy metal-free steel. We also have a food grade version 316L of the SM300. So if you want to analyze heavy metals, you should use heavy metal-free tooling, for example. And now we have a very interesting and nice and innovative concept at SM50. The milling chamber is removable. So here you are able to simply change to another setup, to another material by removing this milling chamber and use a new one, another one, a more abrasive resistant one, for example. And now let's come to the cleaning aspect. I would like to share 2 videos. I recorded them to show you how cleaning looks like. Let's start with the cleaning of SM300. Now, here I milled some dog food, chew bones, and they are a little bit sticky, fatty, I would say, and the residues are quite hard to remove. So you can either use a strong brush to remove it, or, and this is a tip or an idea, you can do a second milling, like a cleaning milling step, as a milling step for cleaning the machine, with the cleaning material. So I selected wood chips here. You can also use any other material that is dry and kind of abrasive. The idea is that you perform a milling process to get away the strong and hard residues from the surface of the mill and of the milling chamber, instead of cleaning with a brush or other tooling. So let the machine do the job. So I simply feed the machine, and of course I throw away the result. It's not important here. And you can see that it looks much better than before. So we have residues still from both materials now, but they are more simple to remove. This is a typical cleaning process using the vacuum cleaner and a brush to remove all the loose particles, the powders, the residues that are left on top of the sieve. So this is kind of superficial cleaning, but there are a lot of laboratories or applications that need a very thorough cleaning of the components. So this would not be enough. And for this, you can remove the rotor and also the sieve and clean it externally. For example, with water, to better be able to clean it more, better cleaning in terms of more thoroughly cleaning. You can always use a wet wipe or some cleaning agents. Please consider that the material and the cleaning agents are compatible. SM300 also offers a possibility to fold back the hopper. This is important because then you can also inspect the hopper in terms of residues, so that everything is removed before you start the next cleaning process. Okay, now let's jump to the cleaning of SM50. Because here we really emphasized all our efforts to design a perfectly cleanable mill. You see, this is the release function. You can freely rotate the rotor for cleaning. We again started with the superficial cleaning. You see, the whole mill is inspectable, also the hopper. With the door opened, you can see inside the hopper, inside the milling chamber, and you can use brush and vacuum cleaner. This is a cyclone, so you do not have any connecting elements like tubes or hoses. It's simply the body and the lid of the cyclone. And here again, the hopper, which is simply accessible. Now we have the removable milling chamber. This is a great advantage because, you know, external cleaning is much easier than trying to clean inside the machine. And even the the channels for the vacuum cleaner can be cleaned at SM50. And now let's go to the external cleaning process. So we take away this push-fit components from the mill and clean them underwater. If they're made from stainless steel, you can also use dish washer, and you can use, for example, a brush or also some tooling to remove the hard the materials, for example, in the sieve, what you have seen at the beginning, and also here underneath the cutting blades, there are always some places where material can hide, and you have to really remove it with some force, mechanical force, to be very sure that there's nothing left back, and to avoid the cross-contamination with the next sample. So many laboratories emphasize how important the cleaning is here. last but not least, you clean the cyclone. And I don't know if you have noticed, but we had a clock running. We stopped the time that we need for cleaning, and here the result is something about 12 minutes. And this is an important point. Many laboratories have not only the idea of perfect cleaning results, but also to be fast. So if I show you this on a slide, the actual milling process is only a very short period of the whole process. Most of the time should be used for the disassembly, assembly, and the cleaning of machine and components. And if we now look at our new SM50 with the enhanced cleaning features and total access concept, we see that we have up to 30% time recovery or time saving compared to the benchmark models. And maybe you have already had the idea, but what if you are buying 2 sets of grinding tools? You can remove the one for cleaning and directly start with the second one, the next grinding. And the second person cleans meanwhile the other grinding set. So very much faster when you're using 2 grinding sets, only possible because we can remove the grinding chamber. So this is total accept. Again, as a summary, the EasyInspect hopper that opens completely, the push-fed components for external cleaning, and the integrated cyclone, no connection necessary. And from the start on, thanks to the cyclone, you do not have so many residues because it helps you to take out all the materials from the machine to the receptacle. The brush, we give also a brush together with the machine to clean all the other parts. Very easy. And the external cleaning is more comfortable. You have better results. It's faster, even much faster when you're using a second grinding set. So this is also kind of a key topic of the new machine. We recognized how important cleaning is. Time is money. Stop wasting it. And this is why our development team innovated such nice features for cleaning. So let me give you a summary. Cleaning a cutting mill. You can do a superficial cleaning using a brush, vacuum cleaner, compressed air, or you can do the thorough cleaning externally underwater with a brush or and maybe some specific cleaning agents. Some tips. Visual inspection is very important before you start the next grinding process. Have a look at the hopper and all the parts to be sure that there's no remaining. Use the cyclone to have a better output of the material. You can use discharge the first sample quantity. If you have bigger sample quantities, you can also use the first amount of your material, throw it away and say, okay, this is cross-contaminated, but everything what comes now is clean. Or do a cleaning process with a specific cleaning material like the wood chips that I have shown you. You can also do a fast cleaning if you use the cyclone channel itself. And cleaning underwater, remove all the components. It's much easier to clean them underwater. You can also use ultrasonic bath for cleaning the sieves. Sometimes in the apertures, you know, there's this. We have 2 types of sieves: square holes or the conidua holes, and it's quite difficult to remove it. Ultrasonic bath can help you here, and you may use a dishwasher. So this is the summary of our innovative cutting mill features: cleaning in record time, contamination-free milling, high cutting performance, of course, this is the most important point. And up to 100% sample recovery is possible. Let me give you just an overview that we offer some services. We have a very nice homepage with a lot of videos and an application database. We offer service, for example, test milling. You can send us your samples and we mill them, we make pictures, we make videos, and you can decide together with us and our experts which is the best solution for your application. We offer seminars and online demonstration, and we have a worldwide service. Now we have some times for questions. I have already seen in the chat that there are many questions coming in, and there's one question, maybe I have not explained it best way. So let me switch the camera. I said that there are corners or places that cannot be used, or that can better be used when you clean them underwater. Okay. Stop this. Okay, now it's better. So you see, this is a rotor. It's very clean surface, so we do not have, our design team put a lot of effort not to have screws on top or corners here, but there are corners which are not avoidable. For example, underneath the cutting blades or here at the screws, and you can clean them better when you remove the rotor and use running water for cleaning. So this is what I wanted to say, why cleaning underwater is not only easier because you have better handling, but also better in the result. And these are the sieves. We have the square hole sieve, and we have this sieve, which is it's for fine grinding. Everything below 1 millimeter has this kind of sieve design, and it helps you with shear forces to grind the sample material. So you do not only have the cutting of the blades and knives, you also have shear forces here of this design. You can put it in the right direction, which is this one. It's the same idea when when you make cheese into little pieces. It's this direction, that's how it works. But you can also place it on the wrong or the other way around, a reverse side, which can be helpful when you have fibrous materials, so that fibers tend to break and not to pass the sieve lengthwise. So this was the question for the sieves, and I have seen 2 more questions for the device. So I change camera. I said that you can use the cleaning channels to clean the milling chamber. So normally you start with the vacuum cleaner and clean all the positions where you see that there's sample remaining on the surface area or wherever inside the milling chamber. What you can do is that you remove the rotor and the sieve, and you use the cyclone channel. You close the door. Now the air is sucked between from the hopper through the milling chamber. You tap the opening and you start the vacuum cleaner, and then it's a very fast cleaning of the whole system. Of course, we are only talking about superficial cleaning here. And from the cyclone, there was another question. I hear it very often. Of course, cyclone technology also depends on the power of your vacuum cleaner. So make sure that the vacuum cleaner is not full, so that it has an empty bag and it's really working. So you have the pressure drop that you need. We also recommend a specific vacuum cleaner, but you can use every typical vacuum cleaner from labs. And then the vacuum cleaner is not sucking the material, but the cyclone separates the material from the airstream. Of course, if you fill the glass too full, if you overfill it, or the sample cannot fall into the glass anymore. You see there's a movement in the glass. You start sucking material from the glass into the vacuum cleaner. So our recommendation is only to fill up the glass up to 2/3 and then use another glass. Or use a bigger receptacle, 3 liters for example, so that your sample fits properly in the receptacle and you can use the vacuum cleaner technology. At the end, if we are talking about very powderous, fine materials, it is always better to use a cyclone because the residues that you would have without cyclone, so the dust that comes out from the machine or what is left on top of the sieve, is bigger than the portion that is lost in a vacuum cleaner. And there was one last question. You see here in SM300, we can change from the gravity chamber to from the gravity outlet to the cyclone system. We also offer for the SM50 a gravity chamber. Normally, we recommend using the cyclone. This is why it is standardly included. But if you are milling very heavy materials, and if you only talk about coarse pre-crushing, so sieve size of 10 millimeters, 8 millimeters, you can also use the gravity chamber. In this case, the material, I have it here too. In this case, the material falls down into a receptacle and you are not using a cyclone. But there's a limited application for this. Okay, so I think half an hour passed by, always very fast. I hope you enjoyed the webinar. I was happy to have you here together with me talking about our cutting mills. And I hope to see you next time. And I wish you a very nice day. Goodbye.